Hello, this video is going to be an overview of how I'm designing a house from the ground up. I'm mostly making this video to share my progress with friends, but I also think it's useful to stop and reflect on the process. At a very high level, we can think of the process of designing a house as five main steps. The first would be your site selection, finding some land that's suitable to build on in a place you want to live. The next step is pre-design. The third stage is your early design phase, where you're drawing rough sketches or schematics. In the fourth stage, you do your core design development. This is where you're drafting the main architectural plans for your house. And finally, the fifth stage is to finish up your official permit and construction plans. Now let's go through each of the five steps of designing a house in a little bit more detail. First step is site selection. At a very high level, you just need to find some land that's suitable for building. You need to do your due diligence before buying a piece of land. Some of the things that you need to look at are zoning. In my case, it's residential. You need to know if there's any easement or legal issues or encumbrance on the property. You need to make sure that the title's clear and that the property taxes are current. You want to ensure that your land is surveyed by an official land surveyor and the property corners are marked by the surveyor. You also need to be aware of hazards like wildfire, hurricanes, flooding. And finally, looking at the actual land, the geotechnical side is making sure that the soil and the terrain will make it straightforward for you to build your house on. You got to watch out for things like, expansive or clay soils, seismic faults, steep slopes, things like that. The next step after site selection is pre-design. I think of it as gathering requirements or reducing the problem. I'm getting some requirements and some constraints that will help me come up with a design. For example, at the end of my pre-design phase, I had established that I wanted a house with 3 bedrooms. I want a master suite that has a separate bathroom. I'd like to have a balcony with a view. I want to design the building to be handicap accessible or ADA, for aging in place. I want to take advantage of solar heat and power. And I was inspired by the passive house idea of a very efficient house. I wanted to maximize the outdoor area. I want the building to create a windbreak because I know the location can be breezy. And I wanted the design to be inspired by mid-century modernism. I also liked split level designs where you have floors that are slightly offset. The third step to designing a house is the early design phase, where your goal is to create a series of sketches or schematics. What I did is I started by looking at a lot of different floor plans. I did some sketches of just generally where I wanted the different rooms to be in relation to each other and where people would walk, what parts of the building were public, what parts of the building were more private. And I used tracing paper quite a bit to iterate on some layouts and then translate those layouts to more detailed floor plans. Once I got a floor plan I was interested in, I would then move on to looking at the 3D shape of the building, the overall massing, and the orientation of the building. This is an iterative process where you'll go back sometimes and change the floor plan, play with massing, and back and forth. You can even use AI to kind of generate some ideas of buildings, mid-century modern style buildings that have a similar shape. And so at the end of this stage, you'll have a nice, pretty detailed sketch of the floor plan that you like, and you'll have a good idea for the overall mass and shape of the building, including things like roof lines. So in my case, this is what I ended up with. The fourth step to designing a house is design development. This is where you create drawings with the next level of detail. During this stage, you'll be doing the bulk of your architectural drafting and really be thinking through the details. Things that you catch in this phase will save you a lot of time and money later on. And the fifth step builds on the previous one, taking those architectural plans to the next level by adding everything that you need to submit your building permits and give contractors the construction plans they need to build the building. Here I have this great checklist for a single family residential building for the city where I'm building. Well, in step 4, we created our architectural design. In step 5, we add extra details to that for construction drawings. We also have to do our civil engineering design, includes things like roads and utilities. We need to create plans for our mechanical system for heating and cooling, ventilation. We also need plumbing design. This is another set of plans which specify where every drain and every pipe go in your house. Now, before you can get a building permit to build your building, you also need some structural engineering. This typically includes a separate set of plans specifying the framing and the foundation details, which are done by a structural engineer. So that's it. That's a super high level overview of how to design a house from the ground up. Okay, so as some bonuses, let's look at what should we look at? So I think this is a pretty cool comparison. This was the final massing that we came up with early design phase. And this is what I ended up with today. One of the cool things I want to show you about this design is if you see these overhangs here, these are designed carefully to keep the sun from hitting these windows in summertime. Let's look at two solar study animations. The first one here uses the position of the sun at this location in the summertime. Now notice what happens to these shadows right here to the sun. Notice the sun doesn't hit these windows in summertime. That helps keep the house cool and conserve energy. But in the wintertime, we actually want that energy. Now notice the difference in the second animation, which is in the wintertime. You'll see that the sun is able to shine directly on the windows, providing a lot of light and free heating in the wintertime. And that is why the roof overhang here is as large as it is. And I also did the same technique on the garage, this window. Another cool thing to look at would be the plumbing design. So these are the plans for the plumbing. This is the basement level plumbing, main floor plumbing, location of all the drain lines and hot and cold water. Then we have this 3D schematic of the whole system. Notice that I'm running cold water and a drain line out to the garage because I got to have my utility sink. There we go. The main building drain down here in the basement. You got to add up your fixture units. Make sure all your pipes are sized correctly and everything. One of the more interesting parts of this process was learning all the details of plumbing code and how to design your vent system. Not only do you need drains, but your drains need vents, which keeps negative pressure from sucking the water out of this P-trap, which is the only thing separating you and your house from nasty gases that come up from the city sewer. So to keep these little P-traps full of liquid, keeping them from being siphoned out whenever there's negative pressure in the pipes, you have to design a vent system for these pipes that go up just for air. And one of the interesting things was I wanted a single roof penetration. Again, I'm trying to be super energy efficient and I'm trying to design a building to last. So the fewer holes I have through my roof, the better. So I got away with a single vent penetration. And the thing I've been working on most recently is the mechanical design. You have to do some calculations. There's this thing called Manual J where you figure out how much heating and cooling you need, and for each room, a breakdown of how many cubic feet per minute of airflow you need. And then once you know how much airflow you need to each room, you can design your duct system. We have our room by room calculation of area, volume, and heating and cooling load. We have some calculations for determining duct sizing. Uses some calculations to look at velocity of air in the ducts, the amount of friction that the air is seeing through the ducts, and doing all these calculations allow you to design a really well-tuned ducting system that keeps your house at a comfortable, even temperature and is very efficient to run. So that's where I'm at. I'm finishing up these mechanical designs, and then I'm going to be moving on to the electrical design, which is fun. Once I get the structural engineering back from my structural engineers, I'll make whatever changes I need in my architectural model to match that, and then I'm ready to submit my plans to the city for a building permit. Thanks for joining. It was fun to share this process with you. Take care. Bye-bye.